Welcome back to Advent of Code 2024, Day 7. Bridge repair. Yeah. Hello, Smab UK. Have you done this already? Alright, Day 7, Bridge repair. The historians take you to a familiar rope bridge over a river. This is from 2022. Don't remember this one. 2022 actually is actually one of the older ones I did. Okay. In the middle of a jungle. The chief isn't on this side of the bridge, though. Today is solved, but I don't like my solution as it runs just a bit too slowly for my liking. Okay. The chief isn't on this side of the bridge, though. Maybe he's on the other side? When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. What? Are they writing these equations using, like, stickers? They could finish the, or like those, like, things they have in, like, kindergarten, with where you, like, put symbols on the boards. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations. Just thought of a way that might speed it up. Going to try that. Alright. Okay, 190, 10, 19. Okay, so each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Okay. Operators are always evaluated left to right, not according to precedence rules. Okay, that's easier to deal with. Much easier. Furthermore, numbers in the equations cannot be rearranged. Glancing into the jungle, you can see elephants holding two different types of operators, add and multiply. Okay, only two operators. Only 3 of the above equations can be made true by inserting operators. 190 is 10 times 19. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of the test values for the 3 equations listed above is 3749. Determine which equations could possibly be true. What is their total calibration result? How big are these equations? Oof, quite big. But they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They are within the rounds of. So if we were to try every possible sequence of operations, but remember we can cut off the moment the number becomes too big, because this is increasing as we apply operations from left to right. So for lots of multiplies, that will very quickly cut off. So by default, we start with just addition, because that's usually going to be smallest, not always, because if you're adding 1, that would be bigger. But, so we can think of, if we're counting up in binary, we can think of additions being the zeros and multiplications being the ones. That's probably the more efficient way to do it. If we're going to try every possible combination, I think that is what I want to do. Like, you could sort of cache... Like, you can have some shortcuts. Like, you can say that if a certain... Hello, Crayon Crayoff. How's the coding going? Yep, it's going alright. Just started, haven't actually coded anything today. I'm just figuring out how I want to approach this. It looks like this was designed with brute force in mind. Like, the sizes are, like, it's going to be like 2 to the power of 10, 11. So that's like 1024 multiplied by, say, 1,000 results. So millions of operations. I think that's doable. And added to the fact that we can cut off a lot of those, we can prune off a lot of those branches because there's going to be too many multiplications. Yeah, I think that's... But they could give us some tricky examples where there's lots of ones, which would sort of mean we do want to multiply lots. I don't know if they've got any to get a certain number. There might be some tricky examples, so we can't just... We do have to try all the combinations. It's just we cut off as soon as we know it's too big. Alright, well, I think brute force is within... reason. Let's do it then. Alright. So... I didn't even think of cutting it short. That would probably be better. Yeah, well, there's 2 ways you can cut it short. One is... The one I'm talking about is... when we're trying one set of operators. As we're doing this calculation from left to right, we can just stop as soon as the number becomes too big. So that will cut off a little bit, not that much work. In some cases, it could actually halve the amount of work, I suppose. But it depends, really. But you could also... And this is a bit sketchy, but you could also cut off sets of operators that have too many multiplications in, but I don't... But then we could get caught out if he gives us an example with lots of ones. That would be an example where you do need lots of multiplication. So yeah, I don't think we should worry about that one. I mean, just pure brute force, it looks like it'll actually just work. But we can still put in some cutoffs. Alright, let's start coding this. So we've got ints equals line dot strip dot split. What was the term they used? The test value. Test value equals int 0. But you've got to cut off the colon. And equation equals just int x for x in ints from 1 onwards. Okay. I guess we just want to make a method here, define. It's just going to be a boolean that says true or false whether we can make this equation true. Define is valid equation. So we're given a test result and an equation. So just over here, let's just put this here so I know we want I've been trying to practice list comprehension more, so for parsing the input I came up with this monstrosity. Int num for num in line. For line in... Oh, I'm using regular expressions in the midst of it. Okay, find all... For x into input lines. Suppose that... Okay. Yeah, I mean, I suppose that can handle pretty general cases. You could reuse that on several test inputs that have colons and brackets and stuff in that you don't want, but yeah, if it works. So result plus equal is valid equation. Test value. Print result. So it should just be 0 for now, or whatever. Okay, so how do we do this? We want to say... Okay, we definitely are going to be using itertools. What is the exact module we want here? Combination Combinations. I've got to look these up again. Python, iter_tools. So we have two possible values, and we want to try all tuples of a fixed size. Okay, combinations is R-length tuples in sorted order. Product. Product is what we want. Every possible combination. Cartesian product. Equivalent to nested for loop. Yeah. Okay, so product. Product. So for operators in product. So we want the iterable, which is going to be equation. Wait, no. Iterable is just going to be plus star. I guess we can do it like that. And we want it of length equation -1. Doesn't like using a string. I'm pretty sure you can use a string. And let's have a look at this product. Oh, no. Product is not quite what we want here. Ah, no, what we want is combinations with replacement. I always get confused with these different terms. They're all very similar. Is that right? Let me have a look at this example. Combinations with a replacement ABCD 2. That gives AA, AB, AC, AD, BB, BC, BD, CC, CD, DD. Okay. Let's try printing it. It's going to be a lot of printing, but let's just have a general look at this. Yeah. It's like it's counting in binary. But I was expecting this isn't the order I would expect it to do it in. No, wait, this doesn't look right. That's too few. And this fails because we didn't return anything. That's fine. So this is one call. For operators in combinations with replacement. It's not doing every permutation, is it? Am I using... Oh, this is confusing me so much. Combinations with replacement. Returns R-length subsequences of elements from the input iterable, allowing individual elements to be repeated more than once. Yeah. Emitted in lexicographic order according to the order of the input iterable. This doesn't look like it's coming out in lexicographic order. Where's star plus at the end? Confused now. Oh, this doesn't do what I want it to do. Hang on. Combinations with replacement A B C A B A C. Ah. Product was right. Product was right to begin with, because this is only taking maybe regular combinations. Combinations doesn't look right either. I think we go back to product, but I didn't set the repeat value. Product does the full Cartesian product. That is what we wanted, but I didn't set. But you don't set a value here. You have to say repeat. So combinations with replacement is like you're taking things from a bag. And I think it only cares about numbers of things that come out. Actually, I don't know. All I can think of right now is that product is the correct one. Repeat equals length of equation minus 1. Alright, this should... Okay, we've got plus, then we got plus star, then we got star plus, star star, so that's binary. Yeah, this is what we want. And then star star stars. That's the full. Alright. So that's a set of operators. So we want to say P, the product, equals equation 0, the first value. And then we say for O in operators, or, I don't know, no, just in range for I, O in enumerate operators. So we get each operator, but we need the index as well. So we say if O is plus, P plus equal equation I plus 1. So operator 1 will mean we add the second value in the equation, and so on. Else P times equal equation I plus 1. And we could just do that. We could also break early if P is bigger than test value. Break. Okay, so when we've done that, applied all the operators, multiplied it all up and everything, we've got some value. It might have exceeded the test value. If P is exactly the test value, return true. We found one example, and that's all we needed. Otherwise, we just go to the next set of operators. This might take a while to run. So if we exhaust all operators, we just return false. Oh, that was quicker than I thought it would be. 416. Nope, it's too low. Okay. Time to debug. Let's whip out the test example then. So we got 3 on the test example. That's correct. Oh! We're not supposed to just output the number. Ah. We're supposed to sum up the test values. But 3 is the correct number of valid equations. Yeah. But it's not the correct answer. So we just need to result if is valid equation result plus equal test value. So this should be 3,749. Yes. Okay. All right. Nice big number. That's the beauty of Python. Arbitrarily large numbers. It's not that large. Correct. Okay. And that ran pretty quickly. I wasn't sure. I mean, okay, my numbers were right though. It was like we're talking about 1 million operations or so. Wait. How many lines were there in this? It's usually 1,000. 850. Okay, it's actually shorter than 1,000. Yeah, so 1,000 times 2 to the power of 10. But a lot of these are actually fewer than 10. So yeah, it's actually basically under 1 million operations. Okay, part 2. Oh no. The engineers seem concerned. The total calibration result you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding a third type of operator. The concatenation operator combines the digits from its left and right inputs into a single number. My part 2 was about 3 seconds and that bugs me. all operators are still evaluated left to right. Well, the way we've written this extends nicely to this. It's just a question of whether it will run in time, but I think it probably will. Now, apart from the 3 equations that could be made true using only addition and multiplication, the above example has 3 more equations that can be made true by inserting operators. I can sort of see how you can save a lot of time by the order in which you choose operations. Because if we have, say, 5 multiplications in a row, and we're just changing the final values every time we're redoing all those 5 multiplications at the start. So if you chose your ordering, there's special types of orderings which are actually designed for these kind of purposes, like Gray's ordering. I can't remember if that's relevant here. Not Gray's Anatomy. Gray's ordering on binary numbers. Gray code. It's the American Gray. Which, like, optimizes the number of changes. You only change 1 digit each time you go to the next number. So if you... Imagine if it was called Gray's Anatomy Ordering, though. That could be what the show was named after. If you use Gray code, for example, it's only changing 1 operator at a time as you go between them. So you could find some nice way of optimizing, because then you're just... Because it's... the whole process is... What's the word? Where you can swap things around and it's in the equation, it'll still give the same result. I forget my mathematics, but then you could just undo that 1 operation and then redo it with that, and that probably would be a way of optimizing it. Can't be bothered to do that myself, but yeah, Gray's ordering is used in applications for this purpose because it's cool. All right. This operation, I just thought of an optimization, but I don't know if I can be bothered to implement it. Yeah, I've never really done these problems for optimizations, but for like trying to get it below a certain result. Plus, I'm using Python, so it's always naturally a little bit disadvantageous. But I always spend about 5-10 minutes at least thinking about what I could do. Going to try it, should speed things up enormously. Alright, so concatenation is that. Alright, so it's actually in some ways inflates the number more than multiplication in many cases, so that shouldn't be too bad. In fact, it will cut off early a lot of the time. Are we allowed zeros? Let me have a look at the input. From a glance, I don't see any zeros. They probably said like positive numbers or something. Not that it really matters. Alright, so so it's just, okay, just do this now with concatenation, alright. I think it should just work. Let's try it then, so... Let's give it operators. No, but operator symbols. So we supply the operator symbols here. And we just have to use a single pipe symbol. Result 1, result 2. Alright, so we've got, if it's plus, do that. Elif O equals star, do that. Elif O, I mean, we can't just do else, but I'd like this to show what we're doing. What we're looking at here, P, so we want to say P equals int of, let's say, cast it to a string, concatenate it with that, and then cast it back to an int. So we're now going like 3 to the power of x instead of 2 to the power of x, so it's like, it's 3 to the power of 11. That's 177,000, still not too bad, and we're often going to not get that far, so let's see. Okay, it's definitely taking longer. So in the worst case... Alright, there we go. Correct. Like, yeah, I mean, if part 1 was correct, then we expect part 2 to be correct as well. Like, there's not much that could go wrong there, other than doing the pipe symbol wrong. And it's always nice to have arbitrarily large numbers in Python. Yeah, so if I were to optimize this, maybe do something with this gray code would be my first idea. Maybe some sort of caching, although I don't think that's... Yeah, I don't really want to... It's too many different numbers. I don't think we really want to be caching. But would Gray's code approach really make sense with this new symbol? I don't think this new symbol is, what's the term again? Yeah, I've got to look this up now. On Google AI, tell me. Term for when you can switch things around in an equation and... commutative? It's commutative, isn't it? Or associative? No. Yeah, commutative. Is the pipe symbol commutative? No, it's not. It's definitely not. Plus and multiplication are... if you're going from left to right. Wait, hang on, no, they're not. No, commutativity is not what I'm thinking of. We're not actually switching things around. We are... Doesn't actually matter. This property, whether it exists or not, it doesn't matter for Gray's code. The point of Gray's code would be that we undo the operation and then we do it with the new change. So you can like have a checkpoint at that point to know what value it was at that point. Alright, but we're not going to optimize because we have done it. Yeah, that was a nice problem. It was clearly... I mean, it wasn't that mathematical in nature. It's a good practice for computing the Cartesian product, because that's something you have to do, and Python fortunately has itertools which has the right things. If you remember what's a combination, what's a permutation, what's a product. In this case, we want Cartesian product, which is every possible tuple, which is exponential in nature, so you know, in general applications we often won't use products because that's just too many things, but these numbers are small enough. I was pleasantly surprised that today came pretty easily to me. I got hard stuck for a while yesterday. Alright. Yeah, quite a few people got stuck on yesterday's problem. Conceptually it wasn't difficult. I mean, they outlined the steps you have to do. You didn't have to fill in the gaps yourself, but yeah, you just gotta code it carefully and watch out for cases like where you bounce back 180. Apparently, the way some people had written it fell into the trap where it wasn't correctly bouncing back 180. But if you write it exactly the way they've said, try to move forward or turn right 90 degrees and so on, then it shouldn't have an issue with those edge cases. But got yesterday down to about 0.5 seconds in the end. Cool. And I saw some people try to use the interview style approach for the linked list. What's it called? The tortoise and the hare algorithm. For doing it, which I don't recommend doing. The point of that algorithm is supposed to be used on low-level data structures like linked lists. But when you have hash tables, use the hash tables. So it's like loop detection in linked lists. Like, there's a very famous interview question which they love to ask, and that's how to detect a loop in a linked list. And it's where you have one pointer that moves one step at a time and one pointer that moves two steps at a time, and the idea is that the fast one will eventually lap the slow one and they'll meet, and then you've detected a loop. That's cool and everything, but it's like the whole point of this is that you're not using it like hash maps and stuff. You're writing something where you need no additional memory except the locations of 2 pointers. But if we're doing high-level programming, just use a hash set. It's actually faster. Hello, Flynn. That was quick. Yeah, it was not a hard problem. And surprisingly ran quicker than I was expecting. I mean, it ran quicker than yesterday's problem, even though we're basically doing it it's even more brute forcey than yesterday's problem, but with smaller values, so it was alright. My code runs in slightly over 36 seconds. Yeah, mine took like 20 to 30 seconds, I think. Day 6 YouTube mislabeled as 5. Do you mean the published video or the stream? I'll have to check that. Like the published video with the thumbnail? Oh, I've got a bookmark here. Day 6, day 5. Oh, I think you mean the stream. The streams I don't pay much attention to. Day 7. Day 5. Day 5, yeah, you're right. I mean, it doesn't... I can change it later, but it doesn't matter so much, because that's the live thing. Like, no, I don't intend for people to look at that anymore. I intend for them to look at the published one. Um, Here, if you want to see how I did it, okay. Oh, you're talking about yesterday's one. Okay, yeah, I looked at this, didn't I? You were offering that to Crayon. Yeah, I guess Map UK's was. Oh, so this is with the new optimizations. Two factors. You only need to place obstructions on the original guard's patrol path. Yeah, that's a good optimization, and you can start the search from the position before you place the obstruction. Oh, that's a good point. Yeah. So, bailing out, I haven't done this day yet. Well, I wasn't really gonna, I was about to close the stream anyway. I wasn't gonna talk about it much. But, yeah, that's a good optimization as well, so that'll probably cut out a lot of time. Okay, guess I'm done. $13 for... I mean, that's actually believable for a problem involving permutations, because you just... No, I don't know. It's still too fast. I don't know. I don't know what to think about these times anymore. It's still not obvious how they want it to be done. Oh well. Private leaderboard. These times do reek of AI generation. Yeah, I mean, several people have just like it even says in their GitHub like exactly what tool they used. So they're not even hiding it. Like I think maybe a good thing to have would be to have a separate leaderboard for AI only, because I suspect a lot of these AI solvers aren't actually intending to cheat. They just want a leaderboard to put their stuff on, and because there isn't one for AI, they might just be because they want to solve it as soon as it's out, but they don't necessarily want to put it on this leaderboard, but because they're solving it as quickly as they can, it ends up being on the leaderboard. So if there was a separate leaderboard you could switch to, which was AI only, that might curb the issue, because I suspect a lot of them, like a couple of them have actually just apologized and said they didn't really intend to overtake the leaderboard. So maybe having a separate leaderboard for AI only would actually, it wouldn't solve the problem completely, but it would cut down the number of people doing it. Because I think a lot of these people, they just want somewhere to put their stuff. And it doesn't have to be the main leaderboard. Might have to start submitting videos for the people on the main leaderboard. I mean, if it came to that, I think he would just turn the leaderboard off altogether. Like, it just adds so much work monitoring videos and stuff. I mean, you could sort of crowdsource the verification, like people who are suspicious of things will go and look at the videos, but I don't know. Like how in chess there's tournaments for chess AIs, it'd be cool to see which AI solves these problems the best. Yeah, and I wonder if the introduction of those tournaments helped reduce the amount of cheating in chess. I mean, maybe it's too difficult to even determine if that's true or not, but giving them a place to go. The same goes for AI art. Like, clearly there's a lot of hate on AI artists who are trying to pass their AI art as, I don't know, fine art. But there are galleries that are accepting, like, having special exhibits for AI art, and that gives them a place to put their stuff so that they won't submit it in the fine art categories. Or even digital art, which is not intended to be AI. Yeah, I mean, it is interesting to see these AIs do their things. So having an AI leaderboard, that's probably the best thing he can do, really. Um, but I wouldn't be surprised if he just goes the other direction and just turns off the leaderboard. Amaro has yet to do the... So Amaro is using game... What's it called? The game engine to solve these problems. So that one probably is quite natural in a game engine. The running around on a grid with obstacles and stuff. Okay. So that was a short-ish stream. Even day 1 and day 2 took me longer, or about the same amount of time, so yeah, not actually a hard problem. Alright, anyone doing Advent of Code?
I'm gonna go piss, bro.
Oh, that is not Advent of Code. We need the exact phrase Advent of Code. Oh, is this in English? I don't think that's in English. Okay, never mind. Alright. Thank you for watching, and see you tomorrow. Oh, tomorrow, yeah. I should be able to do it tomorrow. Alright, bye-bye.